Hi, today we are going to start a session on synthetic fibers and plastics. This session is brought to you by Navayug Study, which is a study channel, student study channel for middle school and high school students. I would like to give details about how to access our website, which has got all the details required. It is http://navayugstudy. navayugstudy.wordpress.com. You can send any, and this website in fact has got all required details about what all videos that has been covered and the notes related to it. There are ways in which you can submit questions, submit requests for Google Plus sessions with us for if you want face-to-face video conference for clearing your doubts. You can reach us on navayug.study @gmail.com. You can also join our Google Plus community. The link is there on the website. Please do join our Google Plus community, which helps us. It's a community with parents, students, and the Navayug Study faculty, where we can have interactions and doubts being cleared and so on. Please visit the Navayug Study website and also join the Google Plus community, because you can see all the announcements and so on. All right. So let's go back to the topic of today's session, which is the synthetic fibers in plastics. Just a moment. Okay, fine. So we are going to start off discussing about synthetic fibers and plastics, and I would like to tell you that in this session you are going to come across with many new chemical names which are organic chemicals, which I know that you have not learned organic chemistry, so you may have to recollect a little bit of that, right? So please do keep those chemical names in mind, because you're going to deal with different types of plastics, and each of them are composed of different types of chemicals, and you may have to remember those names. But I'm sure by maybe 10th or 11th standard you would have covered enough of organic chemistry where these chemical names will be familiar and you will really know how its structure is and so on. But right now I'm not will explain that because you're not covered organic chemistry. Okay, fine. So that's the introduction about Navayug Study. Let's get into the topic of discussion, which is, we'll start off with natural fibers, right? So what are natural fibers? Now there are several examples of natural fibers that you find around you, which is used for making textiles, right? And these natural fibers the origin could be from plants or it could be from animals, right? So if you look at natural fibers, there could be plant fibers. Examples is cotton, jute, right? And the cotton thread is made out of the fiber which you get out of the cotton plant. Same thing with jute. Again, the fiber you get out of jute, which is made to make the jute thread, and from there you make clothes and various materials which is used in textiles. I'm sure you would have worn cotton shirt. You would have also worn jute dresses, which are of pretty much fashion. And in fact, our country, India, was the main supplier of cotton for many years, right from BC all the way to AD, right? And if you look at even during the times of Indus Valley onwards, the cotton has been exported from India. So cotton was one of the greatest products, just like spices and metals and so on, which India was rich in, and we knew how to create cotton threads and send it to different parts of the world. So the cotton is a very important and premium product which India is to have, and that's why if you look at our general dressing style or pattern across India, we actually use cotton quite a lot. And So cotton is a fiber which is a natural fiber which comes from plants. Then there are animal fibers, right? Like wool and silk, right? Wool is coming from the sheep, right? Uh, and silk from the silkworm. Absolutely, students were saying the silk from the silkworm. That's right, right? So wool from the sheep and silk from the silkworm. All these are fibers which are coming from animals, right? So you have plant fibers, animal fibers, and wool is also used for making woolen clothing. I'm sure that people who are in colder regions in this planet will be using woolen clothing to protect themselves, and that why the wool protects you is something which I've explained in the seventh standard topic of heat. So if you want to understand how the wool gives you a warm, cozy feeling to the body, please go and look at the heat sessions which I have, which explains about that. Okay, now used to make fabrics for clothing, right? So that's what. So we use fabrics, the cloth, which or the textile using which the shirts, pants, and saris and dhotis and all these are being made for people to wear. Okay, fine. So that's about natural fibers. Now, what does this fiber consist of? So now, if you look at natural fibers, right, that is what is coming from the nature, right? But what about artificial fibers? The artificial fibers are the fibers which are created by human beings, right? Where we make these fibers out of petroleum products and coal as a raw material, and from there we produce these different types of artificial fibers like nylon, terylene, polyethylene tetraphthalate, PET. All these plastic containers are all made of PET, right? You might have seen the plastic jars used in the kitchen by your mother for storing things are all made of PET, the polyethylene tetraphthalate, right? Which is actually organic compound. So we can see these details later on. So nylon, terylene, rayon, right? All these are examples of artificial fibers which are created by certain chemical processing, right? Which is widely used. So natural fibers are made from simple chemical molecules. Sorry, we'll get into that. It's actually a chemical. It's a organic compound, right? So student was asking what is tetraphthalate. So what I was saying is it's an organic compound, and we'll be looking at this in detail later on, right? So we'll be discussing about nylon, what does it have, how is it produced, what is it used for. Similarly, terylene, polyethylene tetraphthalate, all these we'll discuss, right? About what it is and how it is used. Now, before getting into all those artificial fibers, we should know what does the fiber contain? What does it have, right? In fact, artificial fibers have been manufactured taking hints from natural fibers. So the human beings examined the natural fibers closely and understood what does natural fibers have, and use the same concepts to produce the artificial fiber. So in fact, we have taken the concept from the nature and we have used that to produce the artificial fibers. So what does natural fibers have? Let us take example of cotton, right, which is a natural fiber. Now, the natural fibers are made of simple chemical molecules called monomers. And these monomers are the basic unit of a fiber. Yeah, so inside there are these chemical molecules which form a chain. So how does a chain form? So if you look at a chain, it's like this, right? A chain is like this. So this is how a chain is, right? Have you seen a chain? This is like this. Chain is like this. And how is a chain formed? You have got multiple small rings which are put together to form a chain. So, and all these rings are of equal size. They're same rings, but they're put together one over the other to create a chain. Same concept is happening in the case of a polymer, where we can compare one ring to a monomer, which is a chemical molecule, right? So monomer, so and we have several of these molecules chained together to form a polymer. Several of this chained together to form a polymer molecule. Right? So several of monomers are joined together as a chain to form a polymer. That is what is basically happening. Right? We'll get into the details. I will show you exactly show figures on how the monomers are put together to form a polymer soon. But I'm just giving a analogy to a chain, right? A steel chain or metal chain where you can see many rings are put together to form a a chain. Same analogy can be used to explain a polymer, right? Okay. Sorry. Back to okay. So I would like to, in fact, show you. And and in all natural fibers, monomers join together in large numbers to form a long chain of molecules called polymer. Right? So I want to just show you quickly how this happens and how does it look. Right, now this is natural fiber which I talked about. This is a cotton, right? This is how it looks like in the cotton plant or cotton tree. And so you can see these are all cotton fibers, and there are ways of yarning it to form cotton threads, right? These fibers are put together to form cotton threads. So this is an example of a natural fiber, the cotton fiber, right? So okay, now let us look at what do you mean by a monomer and a polymer, right? Now this is basically a monomer, chloroethene, right? So if you take one molecule of chloroethene, so let us look at this. So one molecule, I have to change the color. So let us take a molecule of chloroethene. This is a monomer. It has got two carbon molecules, two carbon atoms, three hydrogen atoms, and one chlorine. Not necessarily four, it could be hundreds of them, right? So yeah, it is more than one, but typically it will be many, right? So you look at this. So I have got a chloroethene molecule, and there are multiples of them. Now if you are able to put them as a chain, that can lead to a formation of a polymer, right? So look at this. Sorry? So look at this. So again, to explain, so this is a chloroethene molecule, right? And there are multiples of them. If we are able to chain them together, that can form a polymer. So you can see that is what's happening, right? So you have a monomer. So this is a ethene. So that was a chloroethene. Yeah, so you can see there's a chloroethene molecule. Yeah, so that was a chloroethene molecule. Mm-hmm. So yeah, so look at what happens now next, right? So now you can see many join together. They form a poly. So this is a polychloroethene, PVC. Have you heard PVC pipes? Have you heard about it? PVC pipes. People say that it is basically called polyvinyl chloride. So what is that? Just a moment. So this is so you can see this is a polymer. The many chloroethene molecules came together to form a polychloroethene molecule. Yeah, poly means many, right? So you are basically trying to chain together many chloroethene molecules to form a polychloroethene molecule, and that actually is a polymer, right? And they are used for creating pipes. You've seen this plastic pipes, right, which is used in plumbing. They are all made of this kind of a polymer, right? And there is a chemical process using which you can do that, and that is what is called polymerization, right? When many monomers are chained together to form a polymer, that process is called polymerization, right? And that is how that polymerization leads to lots of, so that's what basically happens. See, lots of monomer molecules combine to form a polymer molecule. That is what is polymerization, and this is an example, right? So this is polymerization. Correct. So you can see, right? It is chain of these molecules, right? It is still the chain of that molecule. So it is just that somehow they have been chained together. So the basic unit is that monomer molecule, but those monomers have been chained together to form a polymer molecule. Got it? So that is basically what is happening. And so when you chain these monomers together, which is a process called polymerization, that leads to formation of a polymer. So here we have a polychloroethene molecule being created from several chloroethene molecules. Okay? So just once again I'm showing, start again. So you have a multiple chloroethene molecules, right? Then they combine together to form a polychloroethene molecule, right? And you can see that still the basic unit is still the monomer, which is the chloroethene, right? Which have been chained together. So I hope you understood this very clearly. If you have any questions, please let me know, right? Through my website, right? And we can discuss it further. So now, so if you go down, so you can see several examples. So you have a monomer polymerization leading to N molecules. Many molecules of the monomer linked together or chained together to form repeating units, right? Which basically leads to formation of a polymer molecule. So here you have seen you can see two examples. This is ethene. This is the ethene molecule, right? And ethene, or you can say ethylene, right? It's called both, right? Ethene or ethylene. So this is an example of an ethylene molecule or ethene molecule, which basically many of them can be combined to form polyethene. Polyethene bags. I don't know whether you've heard polythene bags. People say polythene. Did you take that polythene bag for storing those potatoes? People say. Do you see those bags using which you carry things, vegetables and all that from a shop? The plastic bags. That is polyethene bags. Right? Similarly, the bags that you use, the plastic bags that is used for covering biscuits and all these, they're all polyethene bags, right? In short, people say polythene, but it is polyethene, right? Where multiple ethene molecules have been linked together or chained together to form polyethene, and that is what you see as plastic bags and all that.
But plastic bags will do a lot of reactions.
Plastic bags, yes, so these polyethylene bags cannot be used for carrying hot things and all that, right? Typically they're not used for that because they can melt and all that. And other problem with polyethylene is they are non-biodegradable. So the bacteria and fungi, which is bacteria and fungi which is there in the nature, doesn't know how to degrade this, right? So what we can do with these polyethylene is recycle. Take it again, use it and recycle and reuse it for producing bags, right? So we can recycle it. Okay, so that is polyethylene, right? Now this is the example we saw before, chloroethene or chloroethylene, right? Where you can have multiple molecules of chloroethene chained together to form polychloroethene, which is typically used for creating pipes and plastic pipes and so on, right? So this is what is polymerization. So I hope this is clear to you. What is polymerization? Is basically the process of chaining together multiple monomers to create a polymer molecule. So this is a monomer, right? And producing a polymer, right? And in the polymer, if you look at the chain, the basic building block is a monomer, right? Is that clear? Any questions, students? Okay, fine. All right, so that is basically about monomer, polymer, polymerization and all that, right? So let us look at the definitions now, which is there here. Just a moment. Okay, so even if you look at the natural fibers, right, the natural fibers are also produced the same way. It has got a monomer and there is chaining of these monomers together to form a polymer. The same concept that we found in natural fibers is what we are trying to use for artificial fibers, right? Same concept. The polymers contain molecules of same substance joined together to form a long chain or bigger molecule, which is a polymer. That's what we see. We saw the chloroethene being changed to form a polychloroethene. We form ethene, which is being changed together to form polyethene, and so on. So, and that process is what is called a polymerization. Example: cotton is made of polymer cellulose, right? Which is a chain of glucose molecules. So, if you look at cellulose, let's go and look at cellulose, right? Now, this is cellulose. Of course, I know that the chemical is far more complex. Glucose is a pretty complex compound, right? So you can see, but the same unit being, repeated here. So you can see what is happening, right? This is basically a cellulose, and you can see the same block repeated, right? Same block repeated. Polymerization. And polymerization of what? Glucose molecule. So if you look at this one block, it's glucose, right? And several of these glucose molecules are chained together, and that chain is called the cellulose. Yes, there will be many strands of them. This is cellulose. Understood? So that is what's going on, right? So many glucose molecules chain together to form cellulose, and that cellulose is basically the polymer which the cotton is consisting of. And glucose is a natural organic substance. You find it in vegetables, you find it in many places, right? And our body also requires glucose, as you know. So this is basically what it is. So it's a natural fiber made out of natural organic compound called glucose, which is chained together to form cellulose, right, which is a polymer. So if somebody asks you what polymer does cotton have, you can say it's cellulose, and the monomer is glucose. So glucose is the monomer, right? Oops. Glucose is the monomer. Oops. Right, and cellulose is the polymer, right? Clear? Any questions, students? No. Okay. So this is the story about a natural fiber, and you can see the same concept of monomers, polymer, and polymerization is what leads to formation of a natural fiber. No limit, it just keeps on going. It just keeps on going, right? There'll be millions and millions of these kind of molecules chained together, right? Okay, fine. So let us go back and presentation. Oops. All right. So that is basically about the cotton, and the cotton is consisting of polymer cellulose, and the monomer is the glucose, right? So as I showed you. So let us get into some definitions, right? Monomer. What is a monomer? The simple molecules in a polymer. The simplest molecule in a polymer is the monomer, which is the building block of the chain which the polymer consists of. So that's a building block. Polymer, product formed by combination or chaining of large number of monomers, is the polymer. As we have seen in the case of ethene forming polyethene, or chloroethene forming a polychloroethene, or glucose forming cellulose. Right? All these are examples of many monomers chained together to form a polymer. Right? Plastic, a material which can be easily molded into various forms. So if you look at plastic, all these plastics that you see around, they are all polymers of different kinds. Right? So it could be polyethene, it could be polychloroethene, or it could be it can be various different like PET that you saw, right? Polyethylene, tetraphthalate, all these are different types of polymers which are existing, and their properties are different. But plastics generally are polymers, right? Okay. So now Plasticity, the property of a material by which it can be molded into various forms. Right? Now, if you take this, right now, this is an adapter. This is an adapter. And this is made again of plastic. This is some polymer, maybe it's PET, polyethylene tetraphthalate, right? And this is a polymer, and what is the thing? It is you are able to mold it to a shape. So this is a specific shape, and that is a plasticity, right? You are able to mold it in a specific. Now you look at the coating of this cable. Again, it is a polymer. It's again plastic coating. Yes, so everywhere you can find plastics being used and they are moldable, and that is what is plasticity. I want to just show you a simple example, right, of plasticity by showing a plastic molding machine, right? Now this is these are plastic molding machines which home hobbies used, right, for producing using plastic to mold it to different shapes. Now this is a plastic molding machine, right, and you can see these are pellets of polymer, right? This is a pellet of plastics, small balls of plastic which they can put into it. It will melt and then it can be molded into various shapes, right? Now he is putting the pellets of plastic inside. And then this is a mold. You can see this is a mold which inside has got some star shape, and he's putting the mold inside, right? And then he will inject the molten plastic into that mold, and because of the plasticity of the plastic, it will take the shape of that mold, right?
Oh, the melted plastic will come on it.
Yeah, the melted plastic will go into that mold. See, you can see some plastic just spilled out also. Didn't you see that? Yeah, now he will take out the mold. He will allow it to cool down a little and take out the mold. And you can see the plastic which has taken the shape of the mold. See? He's got a plastic which has taken the shape of the mold. Nada? Did you see that? So this basically is, this property is what is called the plasticity, where the plastic has taken the shape of a mold. So this is a concept which is used for all plastics. Now there are different technologies called blow plasting, for blow plasting and all that. There are different mechanisms used for molding the plastic. Let us not get into those details. Tomorrow when you become a chemical engineer or something, or a chemist or something, you learn that, but we cannot delve into those details right now. Right? But you can see a simple example of plastic being molded using a mold, and the property of the plastic, the plasticity, which basically allows it to take the shape of that mold, and you can see now a star-shaped plastic piece is being created. Any questions, students? Clear? Okay. Fine. So let's go ahead. So I hope you understood what is a monomer, what is a polymer, what is polymerization, what is plasticity. Everything is clear? Okay, cool. Now I'm going to get into the first artificial fiber, which is called a rayon. Right? Now rayon is actually in fact one of the first artificial fiber that we created. It's also called artificial silk because the fiber, rayon fiber, is very much like silk. It is very smooth, soft like silk, and if you make a fabric out of rayon, it looks like silk, shining, right, and very silky.
Rayon is somewhat similar to silk.
Somewhat similar to silk. That's why it's called the artificial silk. Okay, so let us look at how rayon is produced, right? In fact, it is called the product for it's basically the rayon. If you look at rayon, let us look at rayon and its chemical composition first before getting into how it is produced. So the rayon is actually in fact okay. So rayon is in fact formed by the polymerization of what is called viscose, right, which is again an organic compound. See, this is a monomer molecule, pretty complex monomer molecule. I don't want to name it because probably it will be difficult for you to even understand that, but you should understand that there is again a monomer molecule in the case of rayon, and that is getting changed right, to produce the rayon polymer, right? We'll actually get into the process of formation of rayon fiber, right? How is rayon fiber produced, right? In fact, the rayon also the raw material for rayon is cellulose, right? The same cellulose that you talked about in cotton, right? The same cellulose is the raw material for producing rayon. So, in fact, rayon is not a fully artificial fiber because it is made out of a natural fiber, a natural substance called cellulose. Cellulose comes from plants, right? So I cannot say rayon is a completely 100% artificial fiber because the raw material used for rayon comes from plants, right? So let us look at what is the process of rayon, producing rayon. Now I want you to go to the textbook again on this. You need to understand these steps and remember these steps. There could be questions about what are the steps in producing rayon, right? Right on the other side also. Yeah. There could be questions on what are the steps used to produce rayon, right? So you should be knowing these steps, right? So first step is pure cotton or wood cellulose, which comes from plant, is soaked in third. Wood cellulose is created out of the barks of trees, or the tree stem, the trunk, right? What they do is they take it and then they crush it and
What is the monomer and the cellulose is the polymer?
yeah, so cellulose itself is a polymer of glucose monomer.
So wood should be the monomer.
No, not wood. So wood cellulose is basically created out of the stems and barks of the trees, right? And that in fact inside has cellulose. And cellulose itself is a polymer out of which monomer? Glucose monomer. Absolutely. So that is the raw material used for rayon, right? What they first do is they take the pure cotton or wood cellulose and soak it in 30% caustic soda. What is?
Cellulose xanthate?
Sorry, we'll get to that. We'll get to that, right? So what is caustic soda? Remember caustic soda? Remember about acid based on salts that I taught you, and I talked about caustic soda.
Yeah.
What does it have inside? What does the caustic soda have inside? Remember?
Carbonic.
Nope. Sodium hydroxide.
Oh.
Caustic soda is nothing but sodium hydroxide.
Is
It's a very caustic alkali. Why is it called alkali?
that's a base.
A base. What are alkalis? Bases which can?
Neutralize.
No, the bases which can dissolve in water. Not all bases can dissolve in water, but the bases which can dissolve in water is called an alkali. And sodium hydroxide is a alkali which can dissolve in water. Right? So caustic soda is basically a sodium hydroxide solution. Right? 30% caustic soda means 30% of it is sodium hydroxide and 70% of it is water. So they create a caustic soda solution like that, and they immerse the pure cotton or wood cellulose in caustic soda for around 3 hours. That's the first step. That's the first step. So let us go back and see this. See, you can see cellulose, and there is what you call a steeping tank in which there is caustic soda, and they put the cellulose inside this, and it is soaked and kept for 3 hours, right? Then after that, what is done is it passes through this squeezing. It actually it's passed between these two rolls, which is rolling, which squeezes out all the caustic soda, right? And then what you get is the we get. So let us go back here, right? So caustic soda solution is then removed. So that removing is done by the squeezers. Oops. So these squeezers, so it was soaked in caustic soda, right? Then these squeezers, or what you call a slurry press, removes all that caustic soda from it, and then it is get this, and then the cellulose goes into the shredder where it is powdered, right? The shredder powders it or turns into small pieces, and then that goes into what you call xanthation, right? Xanthation. Now what is xanthation? Xanthation is nothing but a process where the caustic soda solution is removed and the product is warmed with carbon disulfide. It's a gas, right? So it is warmed with carbon disulfide. This is nothing but carbon disulfide, right? It's got one carbon atom, two sulfur atoms. So carbon disulfide, it is actually warmed with carbon disulfide, and that produces what we call, so what happens, cellulose will react with the carbon disulfide and it produces what we call the cellulose xanthate. So that is why this process is called xanthation. Xanthati, I think this is xanthitization or xanthation. Just a moment. Yeah, this is called xanthation. So this process is called xanthation. Right? This process of warming it with carbon disulfide, producing the cellulose xanthate, is called xanthation. Right? So the xanthation. So first we had cellulose soaked in caustic soda. Then after that we used a slurry process to remove the caustic soda from it. Then we shredded it. Then we are doing xanthation, where this shredded cellulose is warmed with carbon disulfide, where cellulose xanthate is produced. Is this clear? You will have to remember these steps. Go through the textbook again. Remember these steps. I'm just showing what is really going on here, right? So you see the xanthation, and this is where the carbon disulfide is applied to this chamber, and the cellulose passes through it, and at that point xanthation happens, and what comes out is the cellulose xanthate, right? So cellulose xanthate is produced, and then what happens? Cellulose xanthate is again dissolved in caustic soda solution to form viscose solution. So now what is happening is that the cellulose xanthate which comes out is dissolved. So you can see dissolver, and inside this dissolver there is again caustic soda solution, sodium hydroxide solution. So the cellulose xanthate passes through the caustic soda solution, and then what you get is what you call the viscose solution. So this is where the viscose solution is produced, and that viscose solution is kept in a viscose aging tank, where it is allowed to just rest there for some time. The viscose solution is produced is allowed to rest there for a few hours, where nothing is done with it. It just stays there, right? So viscose solutions is kept in that aging tank for some time, and then after that it is filtered to remove all the impurities, right? Because you should understand this from a natural origin, cellulose. It will have impurities, could have some soil, mud, some fibers, all those things that has to be filtered out completely, right? So we actually filter that out, and so that is what the next process, the filtering process. It actually, the viscose solution which passes through filters where all the impurities are removed, right? And then it actually passes through so all the impurities are removed, and so you can see all the impurities are removed, and then there is something called deaeration. Don't bother about it. It goes through again filters, and then you can see what you call a spin ret. I want to show you how the spin ret looks like, right? This viscose is passed through then viscose solution which is obtained is passed through what you call a spin ret. So this is how the spin ret looks like. See, it looks like a shower in the bathroom. So the viscose is passed through the spin ret and with some pressure, and you can see there are a lot of tiny holes in it. So through those tiny holes, small threads of viscose comes out. Small threads of viscose comes out, and those threads are basically the fibers. Understood? So the spin ret looks like a shower in your bathroom, in fact, right? So that's what you can see here. Let me go back. So it passes through the spin ret. Here is the spin ret, and then the the threads of viscose come, and those threads or fibers, you can see that actually comes out like that. So you can see the threads of viscose here. So that is how the rayon threads are produced. So you saw all the, once again I'll just tell you all the steps. You have the cellulose, it is soaked in caustic 30% caustic soda solution. Then after that it goes to the slurry press where all the caustic soda solution is squeezed out of the cellulose. Then it is shredded. Then after that it goes to xanthation. Okay,
where carbon disulfide is formed?
No, where it is warmed. The cellulose is warmed with carbon disulfide. It is not formed. It is supplied.
And
The
then after that it gets dissolved in the
Yeah,
dissolver?
no. Then relax. So the xanthation, the carbon disulfide is supplied, and the cellulose is warmed as carbon disulfide, which produces cellulose xanthate, right? So cellulose xanthate is produced because of xanthation. Xanthation is nothing but a process where the cellulose is warmed with carbon disulfide, which produces the cellulose xanthate. It goes to dissolver where again it is dissolved in caustic soda solution. Then after that, and that produces
The
viscose solution, and that viscose solution is filtered to remove all the impurities, and then it is passed through what we call a spinneret. And the spinneret produces threads of rayon, right? Threads of rayon. So that is what's happening. So the viscose is forced through a spinneret, a device resembling a shower head with very small holes. Each hole produces a fine filament of viscose, right? And the spinneret is placed inside a bath of sulfuric acid. So you can see that when you're pushing that to, so you can see, right? It is this is a bath of sulfuric acid, and spinneret is spaced inside the bath of sulfuric acid, and then the viscose is passed through the spinneret that produces threads of rayon, right? So as it passes through the sulfuric acid, so here these threads are coming through the sulfuric acid bath. All right, is that clear?
Yeah.
So rayon is called regenerated fiber because it's produced modifying natural fiber. It is not completely artificial, right? It is produced out of the raw material, which is a natural fiber, which is cellulose, right? Though which is cotton or a wood cellulose. So that is basically what a rayon is. I hope it is clear, right? I want you to go through the textbook. It explains very clearly these steps, right? You go through it. If you want, go through this website. It in fact gives more details about the steps. Some of the steps you may not understand. So you can see this is giving each step very clearly what it is and what is happening. Some of these you may not understand. For example, all these things you not learned it till now. So that's why I skipped and going through it. But if you are very keen, you can go through these steps and you'll get better idea. Right? I put this URL in the presentation. You can definitely go through it. Okay? So I hope you understood the steps in which the rayon is produced, which is a natural fiber, which is called a regenerated fiber, in fact, because it is not completely natural. The raw material is natural, right? Because its raw material is cellulose. So that is why it's called a regenerated fiber. It is regenerated out of a natural fiber, which is the cellulose. Any questions, students?
No.
Sure?
I'll go to the next.
Okay, so please do go to the textbook. If you have any questions, please let me know. Right, any of the steps you can understand, please let me know. What are the uses of these rayon? What are the uses of rayon? Rayon filaments are blended with wool to produce carpets. So they blend it, right? So they,
Carpet here is made of rayon?
this probably is not rayon. This is a jute carpet, but so the student was showing at a carpet in the classroom and asking whether it is made of rayon. Not necessarily. There are woolen carpets which is made just of the natural fiber wool. The carpet which he's showing right now, it's a jute carpet which is made of natural fiber jute, right? So, but we can also find carpets which is used in many places which is made of blended, some fibers of rayon and some fibers of wool. So it's a mix of wool and rayon fiber. Rayon filaments are blended with cotton to produce smooth silky clothes. There are rayon saris, right? Bed sheets which are formed of rayon, which looks like a silk but it is in fact made of rayon, right? Then long filament of rayons are used to make reinforced automobile tires. So if you look at automobile tires, right, down under you can see the rayon fiber used, a net of rayon fiber used. So again there the rayon is used, right? So all these are very much different uses of rayons. So I hope today I'm just concluding the session. I want to sum up what all we have discussed. We just looked at what do you mean by
We saw now what are natural fibers. Natural fibers are made of two types, which is natural fiber and artificial fiber.
no natural fibers of two types, natural fibers.
And animal fiber.
Okay, yeah,
And then after that we looked at chemicals like.
Then we looked at
We saw monomers and polymers
yeah.
made of chloroethene molecules, and when they get chained together, they form a polymer, which is a polychloroethene molecule.
Yes, yes.
We saw the process of
Polymerization, correct. Yes.
And then after that we
Discuss about one polymer called rayon, which is called regenerated polymer because the raw material is a natural fiber, which is the cellulose.
And then we defined monomer and
Polymer,
and
yes.
then we saw what is plastic and what is plasticity. We saw a plastic molded machine.
Yes.
A molding machine.
Yes.
When they put a plastic through inside that machine, and then after that they molded. No, you put it. They put that and then after that they molded that plastic. And
Yes.
and there was a depression.
Absolutely, absolutely. Then we looked at rayon, which is a regenerated
We saw
polymer.
the process of making rayon.
Rayon, what are the steps, and how the viscose is produced, and how viscose is pushed through a spinnerette in a bath of sulfuric acid to produce threads of rayon. Okay, so we'll continue further, and we'll look at more artificial fibers. We'll look at nylon. We'll look at polyethylene tetraphthalate. We'll look at terylene. All these various other polymers and what they're composed of and what are the use. Yes, that's right. So we'll look at all these various polymers in the upcoming sessions. So we're concluding. Again, this session is coming from Navayug Study, a student channel. Please go to the website which I talked about. The website which you can refer to is http://navayugstudy.wordpress.com, right? And you can get in touch with me through email, navayugstudy navayug.study@gmail.com, right? Do also join our Google Plus community. You can find the link in our website, and make use of the website. In fact, I'll be keeping on updating with the links on the videos and the notes that we have in the classes. All those will be updated on a weekly basis in this website. So it's a very good reference point than going to the YouTube, because YouTube is not at all structured, which has got a random set of videos, but the website is very much structured. I would like to show you the website quickly. It looks like this. So this is our website, navayugstudy.wordpress.com. So please do visit our website. It's got all the details. Class 7, you can see Class 7 now. Class 8 is going to be added soon. And you can also have forms to submit for questions, asking for Google Plus session, right, and all that, ways of contacting us. Everything is there. You also have links to our Facebook page, which is not in fact very active right now. I would rather want you to join the Google Plus community, which is far more active, where the parents, students, and the faculty is there together. That's it. Have a great day. See you soon.